Good morning.
Um,
My name is Franklin Gutierrez from Frontnet Networking, live from Miami.
Hi, Franklin. Hi, everyone. Lucas here from Algcom company, directly from Brazil. Thank you for joining us today in this webinar. I'm here as well with Erica Cervelli, my colleague from the International Business Department. Hi, Erica. How are you doing today?
Hello, guys. Nice to meet you all. Thank you for joining us today. We are presenting the webinar about the Algcom products. I am Lucas' colleague, and we are on usually working for the department, international department, on the countries, and always establishing contacts.
That's right. We are just going to wait a few more minutes. Okay, I think we have more people registered. So if you could please just wait maybe 3 or 4 minutes, so the ones that haven't arrived will arrive. We are also waiting for our application engineer, Felipe Rodriguez, which has more than 10 years of experience within ALGCOM. So he will be at your disposal to answer any kind of doubt or any kind of request you might have about ALGCOM products. Okay, so just going to ask you a few more minutes. I'm sharing my screen now so you can check the presentation, and then we'll begin in 2 or 3 minutes. Okay.
Yes, any question you can write down on the chat. Erica will be answer any of your question.
That's right. Any doubts, please let us know. We will be including them along with the presentation. So we'll be replying everyone.
Just confirm if you can see my screen. I think it's all good, right? Erica, Franklin, can you see my screen?
No, not yet. You have the whiteboard. Do you have to do on the right? Yes, right now.
Déjame ver.
Show.
Ahí está, ¿sí?
Yes, it is.
La ve como que... can you
Yes,
see it like
because we
full
can
screen?
we can see the screen.
Okay, awesome. Yes. Sometimes you just mess up the Spanish, English, and Portuguese.
It's all together.
Yeah, we can. 2 more minutes. We can start it.
Sorry, come again?
Yes, give it 2 more minutes and we can start. 2 more minutes waiting for more people.
Yes. Okay, maybe... Okay, maybe we can start slow, right? And then people will enter, and then we just go slow on the presentation. Just like as a matter of respect for the ones that already arrived here. Okay,
Okay.
so just start slow, and then if people just enter, we just ask them to use the chat tool to write anything they need, and then we have Felipe and Erica here also to help us in this matter. Okay, so let's begin. Hi everyone. Again, as I mentioned, I'm Lucas Rossi from the International Business Department of ALGCOM, and today we're going to talk about our solutions of point-to-point in 5 gigahertz. This presentation is brought by Fornet Networking, our authorized distributor in United States in Miami. Okay, so before we started, let's just see about ALGCOM portfolio and how we are not just a manufacturer of 5 gigs antennas. Okay, today we're going to talk specifically about 5 gig solutions of point to point, but ALGCOM has a huge portfolio when it comes to telecom solutions. Besides 5 gigahertz antennas, we work with microwaves, so that means antennas that work outside the free frequency. We also have what we call nowadays horns, so asymmetrical and symmetrical horns for point multipoint solutions, as we brought this new concept to the market. We have DC UPS. A DC UPS, it's a product, is an equipment that rectifies the energy, so it transforms the AC energy to DC energy. And why is that? Because our telecom products work with DC energy, and also feeds the equipment and the batteries. So that means it's two products into one, and it comes with a lot of energy protections in the in and out of energy. And the last line we have, it's outdoor racks. So that means cabinets for external use that counts with a robust material, robust painting, and they're also recommended for diverse types of applications. We have 6U until 24U of height of outdoor racks. Okay. Besides other accessories you have as cable, as armor box, and anything someone must need for its point-to-point and multi-point solution. Just as a matter of fact, Algcom is located here in the south of Brazil, here where Erica and I are at the moment. Okay, everything we produce here in Algcom is Brazilian. So we are really proud to say that we are exporting Brazilian technology because the antennas are 100% made here with Brazilian technology, with Brazilian people, with Brazilian material. Okay, and we are fortunately being able to export our solutions to other countries. And why is that? Because Algcom realized that the pain of the client, that means the thing the WISP here in Brazil is struggling about, is the same as other countries. So what is the biggest struggle we have here in the WISP market in Brazil is the interference in 5 gigahertz. So we realized 5, 6, 7 years ago that this interference in 5 gig was happening in other countries, and then we started to provide our solutions for that scenario to other countries, and now we are over 31. Okay, it's also curious to see that even in Asia, you know how Asia we have China, which is basically the biggest competitor we have nowadays when it comes to cost, because China produces a lot of things in really low cost. Even for those countries that are really near China, Indonesia, Vietnam, the Philippines, India, in New Zealand, Australia, even though they are really close to China, they're still buying ALGcom. And why is that? Because the internet service provider there realized that it's not just price. Okay, they're looking for quality, they're looking for high performance equipment, and that's why they are buying from the other side of the world. They're buying from Brazil, okay, instead of buying from China, because they do understand that quality matters on their links, on their backhauls. Okay, of course we have channels there. Okay, it's not like we sell to the clients directly, but we manage to develop channels there. And in the United States we have Fornet, which also supplies to the whole Latin America countries. As we're talking about quality, we just bring this nice image here from a client that sent us a few months ago. Okay, it's a post on our Instagram page. Basically, this client is telling us that he has this antenna deployed for 10 years. And of course, I mean, it might not be surprised that antenna is lasting 10 years because that's how they should work, right? I mean, they'll be in the weather for quite long. But what is interesting in this picture is that this antenna was developed, was manufactured 10 years ago, and pretty sure it was working with other radios, right? Because back in 2010, we used to have the more simple radios, the ones that work with N protocol, right? And the antenna, of course, was working with those radios. But even though the new technology came, or that means the radio manufacturers came with new radios, radios with AC protocol, with more power, the antenna was still able to work with these radios, right? This is the concept we call future-proof products. We say ALGcom antennas are future-proof because they are ready for the future. In this case, the technology it has was prepared for the technology 10 years longer. So we have now Mimosa C5C, we have the radios from the rotor board or ubiquity radios that work with AC protocol, powerful, and the antennas are still compatible with these radios, okay? Let me already tell you, Algcom does not manufacture radios, okay? We manufacture antennas, but it is our commitment to be updated with the radio brains. And that's why they are compatible with any radio in the market, okay? So if a radio is 5 gigahertz and the antenna of Algcom is 5 gigahertz, they will work. Mimosa, Ubiquity, Microtake, Cambium, LegalWave, Infinite, any radio will be compatible with antennas of Algcom. Moving on, as we're going to talk about antennas, just to have a sneak peek on the antennas we have, as I mentioned, not only free frequency, okay, but from 1.4 gigs until 20 gigahertz, and solutions for point-to-point and point-to-multipoint. When it comes to point, we have 5 lines, okay? So dish antennas, the first one, ultra high performance, the UAGPX, the microwave, as I mentioned, and the grid antennas. Today we're going to focus on the 3 lines above, okay? Dish, UHP, and UHPX. Just as a matter of fact, the last one we have, which is a grid antenna, was actually the first one we started to develop, okay? Here in Brazil, Algcom started to to supply to the big telecoms in the market. You know, those big telecoms we have here in Latin America, like Claro, Vivo, Team, those big telcos that work in the low frequency, and that they were our first clients. And after 15 years, they're still our clients. It is really interesting. But just after we started to develop this market, we went to the small and medium WISPs, the market, the part of the market that works in the 5 gigs. Okay, and that's how we started to develop 5 gigs antennas. About 5 gigs antennas, as I mentioned, the three lines we are going to see today are these three ones. And we are going basically to understand why they are so different. I mean, what makes them, especially the last two ones, to have this performance we are so insistent, you know, we are promoting so much. Why are they working as they are? What are their advantages and differentiations for other brands? That's what we're going to see today. Of course, a dish antenna, it's a simple model, right? Lots of people just compare it to the rocket dish. Yes, the concept is the same, right? A dish antenna, that means it has a good main lobe, the lobe where I'm going to link with my other antenna. But as a dish antenna, its concept does not allow any kind of shielding, any kind of minimizing the interference. So what does this mean? This means that this antenna, a dish antenna from Algcom, from mother brains, it will have side lobes, it will have back lobes. And the side lobes, back lobes are interference and are also a door for the interference. That's why we say an antenna, besides generating interference, it's also hearing interference. Okay? What happened in a UAGP? Why is this model so different than a dish antenna? Check its plate. Okay, it's of course the material, all the antennas are aluminum, but the concept of the plate is already different. Okay, this concept is what we call deep dish concept. It's usually a concept we see a lot on the microwave antennas, and that's why we say also that ALGCOM brought the concept of microwave to the 5 gigs. That is the truth. Okay, that's how ALGCOM highlighted its brand in the market in Brazil 10 years ago, because we started to develop, to introduce to the market deep dish concept in 5 gigs. What does this mean? That now the antenna does not have side lobes, does not have back lobes. It is protected against the 5 gigs interference. Okay, what happened is that the, happened this whole movement in Brazil a few years ago, that the WIS market started to move from 2.4 gigs to the 5 gigs. Just to have an idea of how big Brazil is, we have more than 14,000 small and medium WISPs. So can you imagine 14,000 WISPs moving from one frequency to the other? I mean, it was obvious that the 5 gig would get saturated, right? And that's the solution we brought to the market. So one now has a robust solution to work on 5 gigahertz. And at the end, the
Just
just
one observation. This is why we call our antennas being shielded, right? We always say electrical antennas or shielded antennas. This is Lucas can correct me if I'm right, but this is what we mean. While a dish antenna doesn't have the protection and the isolation of the interference, the UHP and UHP X line, they have this deep dish, and this is what we call that they have the capability and the possibility to isolate noise. So when it comes to our antennas for these lines specifically, they are isolating noise, and this is the concept we bring, being shielded antennas that can work and perform well under interference levels.
That's right. When we say shielded antennas, that's what we're talking about. Okay, deep dish concept. And for the UHPX, besides the deep dish, you can see the reflector. It has the extra shield. That's why it's UHPX. It's an extreme antenna for scenarios with extreme interference. And here we can pretty much see the difference from each concept. So that means, of course, one cannot see the radiation pattern when it's in the tower insulating the antenna. But basically, the engineer's guide, they do the simulation before come up with a product, because we need to understand how it's going to behave in the field. Okay, so a dish antenna, as I mentioned, it is really clear that it has side lobes. Okay, you can see side lobes here at 90 degrees. That means one antenna that it's above the dish will hear the interference from this one. Okay, the concept here does not allow any kind of shielding, which is totally the opposite of UAGP and UAGPX. You can see the antenna was prepared. That means the radiation pattern was prepared for a shoot. So basically, we are optimizing the main lobe and reducing side lobes and back lobes. Okay, for the UAGPX, of course, the extra shield also helps to have and optimize an even better main lobe on its radiation pattern. Okay, that's how they differ one from another. The concept that allows to shield the noise more than the other.
This is going back a little bit there on the the UHP and the UHPX, as they deep dish. As Lucas mentioned, they have a really small silos, right? Which means that we have a small main lobe. We don't have side lobes, and we have very small main lobes. What does this mean? It means that when aligning the antenna, it becomes a little bit harder to make the first alignment. So you may not have the alignment perfectly done for the first time or the second time you're trying to do. And if you don't know the Algcom antennas yet, this might be a little challenge for you, but this is where we tell you this is quite normal because we have small main lobe, which means it's a little bit harder to focus the alignment. But when you do, it gets the performance done. And Lucas can help me there. But with the small side lobes, you have better performance, right?
Yes, actually the angle, right? The angle of the main lobe, the beam width we call, it's smaller. So that means it will be trickier to get the alignment, but once it does get the alignment 100%, you just have the whole performance we are telling you about. Okay, just of course it's a concept. Also, the bigger the antenna, the smaller the beam width, and that means the harder to get the alignment 100%. And of course, as Erica mentioned, it might be a little frustrating at the first time you're using Algcom, but that's something you just get used to because most of the antennas come with a support, with a robust support where you can define adjustment. So that means it's easier to do the alignment and gets 100% of the beam width of one antenna to the other. But that's indeed a reality. Moving on then, another point interesting to check about the antennas, and not only ALG, right, but any kind of antennas in the market, it's about its frequency range. Our UAGP and UAGPX line, they come with the with extended frequency range. So that means an antenna that works from 4.9 to 6.4. Okay, other lines of antennas, a dish antenna, the one that 38 dBi, a grid antenna, each one has its own frequency range. And it's important here when you're choosing the radio or setting the radio configuration to set according the antenna's range. Okay, of course, if one gets a B5C of Mimosa with a dish antenna and sets the radio in 6 gigs, it's not like the antenna won't work. Okay, it will work, but it's not going to perform as well as it should because the feeder was not calibrated, was not manufactured to work outside this frequency. Okay, it's going to work, it is, but not as good as it should on the frequency that was calibrated to. Another interesting point to check about the antennas is about the gain. You know how the gain is not a single number, right? So if I'm telling you that a 2-foot antenna is 30 dBi of gain, the antenna does not have 30 dBi of gain in the whole frequency range. We've just learned that UHP work from 4.9 to 6.4. Okay, that's an extended frequency range. It is impossible for an antenna, or almost impossible, to have the single gain or fixed gain in the whole frequency range. What we have, though, is a stable gain. So that means there's not much variety in the whole frequency range for 4.9 to 6.4, and that's indeed not something easy to develop. Okay, of course, if an extended frequency range has a stable gain, it allows you to play with the allocation of channels. So you're taking your spectrum analyzer, and then you see that the 5.2 is just too saturated. You have too much interference there. You want to go for the 6.1. You know the antenna, this Algcom antenna, will have really similar gain in 6.1 as it had in 5.2. Okay, that's the benefit of an antenna with a stable gain in the whole frequency range.
This is a good thing, this allocation of channels, because you don't have to change the antenna you have. Sometimes when you don't have this extended range, you might have to change the antennas to get the frequency you might need. So this allocation of channels allows you to play with the frequency range, and also going up and down without having to change the actual antenna. This is a quite good thing, and it saves a lot of time and sometimes money as well.
That's right. And also, since we're talking about radio, about channel allocation, of course, the bigger the channel you have, I mean, 20 megahertz, 40 or 80, of course, the more noise you are prone to hear, right? But since the antennas are shielded, it's pretty much logical that you can use bigger channels because the antenna will be protected against interference, right? So that's another benefit. Then you can start to play with bigger channels as the antenna is shielding the noise on your spectrum. Okay. Another point in here is pretty much one of the secrets of Algcom is about the feeder. Okay, so the feeder is this part of the antenna. It has, of course, this back, but it goes up to the front with the lanes. Okay, that's the whole feeder we call. And why is it is so different? Checking this first image. So basically, this one is a feeder from Algcom. Okay, the one in the right is from another manufacturer. Just by the visual, by the it looks, we can pretty much say that the one of Algcom is way more robust. And since it's more robust, it will perform better. Okay, and why is that? Because everything Algcom does, everything we do, we develop and manufacture has a reason. Okay, that's something. It counts for antennas. It goes for the DC UPS. It goes for the cables, for racks, for everything. Everything you do, every screw we have in the antenna, every material we use, it does have a reason. About the feeder, so the first one, the shape of the feeder, okay, it's a square shape. Why is that? Because the square shape is the shape that allows the antenna to work in the extended frequency range. So we can pretty much say by the feeder that this antenna is either UAGP or UAGPX, because those are the models we have in point-to-point that work in the extended frequency range. If you look at our horns, we do have horns, right? The symmetrical horns. The horns will have a square feeder. And why is that? Because the horns as well work with extended frequency range. Okay, so the material also is aluminum, really robust material. The connectors here are at this position. So you have one at your left side and one at the
Upper
uh,
side.
yes, on the upper side. And why we don't have a connector at the bottom? Because if you put a connector on the bottom, the humidity that is inside the feeder will damage the connector. Okay, of course it won't enter water. Okay, it's not that you have water inside the feeder, but you have humidity. Okay, depending on the scenario, you have a lot of humidity, and the humidity will interfere in your connector. And that's why we also have the drain holes here. You can see two little holes. This is where the humidity must leave from the feeder, and it's not damaging, it's not affecting any kind of connector at the bottom. Okay, so that's another reason, that's another thing interesting to see, that everything was thought when we were developing this feeder. Okay.
Just on the squared feeder as well. As you have the drain holes, we always indicate to put it on the upper side, as Lucas mentioned. But sometimes it happens that you forget or something like that. So it's always nice to remind you that the upper one should be on the upper side, and we have a indicated on this red part in the middle, this LUN, where it says LUN. It also says that it should be on the upper. And mentioning about how Lucas said about everything is developed in Algcom, it's thought out. Some time ago, we didn't have this squared feeder. We had another form that was a
Circle rounded form.
Exactly. And we saw on the market's demand, we saw an opportunity, and we saw that we would have to update this kind of feeder. And here you can see exactly how everything we do, we are always looking for thinking about it exactly. So with this squared feeder here in Brazil, at least, when we launched the antennas, it was crazy because everyone was so interested about how we managed to do an antenna with the extended frequency range. So everyone became very crazy. It made a lot of noise with these antennas, and well, we are in the UHPX line. We are very, very, very present in the Latin America. So here you can see exactly how everything is thought out, right?
That's right. That's right. Including can now start to compare with other antennas in the market. I'm not saying that all of them don't work. Of course, we have pretty good brands in the market, especially in Europe, in North America. And here you can see that you cannot compare an Algcom antenna with another made in China or in Turkey or in India. Okay, they have a lot of manufacturers there, but by the look of the antenna, you can pretty much say that the quality, the material, the concept, it is similar to the ones that we have as high standard companies in Europe or Comscope, RFS, Andrews, these kind of companies. Okay, and that's because everything is taught and everything is aimed to perform or aim to the higher quality as possible. Another point then we've seen the feeder, right? In at the bottom of the feeder we have the lanes. I told you the feeder was one of the most important parts of the antennas. I think the most important it's the lanes. Okay, here we have basically one third of the engineer of the antenna, or one third of the cost, one third of the development of the antenna is about the lanes. And why is that? Because the lanes is the one that gives the antenna, or one of the important things that gives the antenna the radiation pattern that we're used to. Okay, it's really easy or really common to see on the internet the radiation pattern of the antennas, right? We promote there, the antennas manufacturer promote the radiation pattern because it is important when it comes to alignment. But before the radiation pattern of the antenna, we have the radiation pattern of the lens in the plate of the antenna, okay, in the reflector. That's something we don't quite see a lot in the internet, okay? The manufacturers don't promote that, but it's important to understand that the lens has a major a major do okay major a work to do in the performance of the antenna. So here again the material and the format of the lens is taught. We call it a corrugated form. Okay, you can see it has this little hose here. It's a different design because this format here allows the radiation pattern to be as uniform as possible on the plate, on the reflector of the antenna. Okay, that's something you won't find on our datasheet. Okay, you won't find in any other datasheet in the market how the lens is radiating its gain to the reflector. Okay, but it's important to know that they must be something robust. The material also is a material with dielectric, with a low dielectric in the whole band. So that means from 4.9 to 6.4, it has low loss dielectric um, loss. And the material and format of the lens is also really thought, okay, because this is what makes the antenna, or one of the points that makes the antenna to have that radiation pattern we are so used to hear and so used to see on the data sheets.
Yeah, I guess that's what makes the electromagnetic waves go as the form as the engineers thought
Simulated.
out to be. These are the lens, this format, this corrugated form. This is what allows the electromagnetic wave to have the format and the development all together from the engineering. So this is the way we thought out as have the best performance to have the best of the best in the corrugated lens.
That's right. I mean, everything we do, of course, the engineers are simulating before we manufacture. So they do a bunch of simulating on their programs there in the engineer department, and they've done hundreds and hundreds and hundreds of time until they arrived or until they got this perfect radiation pattern we are looking for.
Yeah.
Another point, the Vswr, okay, has to do about the reflected power of the radio. So we are used to say that there's no perfect scenario, okay? So there is a loss of performance or a loss of power from the radio to the antenna. And that's the connector, the cable, the radio itself also lost some power, the antenna. So basically the commitment of Algcom as a manufacturer is to reduce the loss as much as possible, okay? So we must reduce the loss on the cables, the reflected power. The Vswr, which is about the reflected power. So the radio sends, for instance, 30 dBm. Okay, 30 dBm is equivalent to one watt. Okay, 1 watt. 1 watt. Okay, so if we look at the Vswr of the antenna, which is 1.4 in this model, what does this mean? So 1.4. If you look at this table we found on Google, okay, it's not on the datasheet, we'll see that the reflected power of an antenna that has 1.4 ratio is 2.78 percent. Okay, it might be a little confusing, okay, especially because of the English and all, but we can see later as well. You can just grab on the chat. We can clarify that. But basically, what we are telling you is that from this 1 watt we are sending from the radio, 2.78 is being reflected. That means we are not using it. So it becomes 0.972, which is equivalent to 29.88 dBm of the radio power. So basically, instead of the radio radiating 30 dBm, we are radiating 29.88. This might sound a lot, okay, because you're just losing power here. But if you look at the antennas in the market, it's really common to have antennas with a Vswr of 2.0 or 3.0. So can you imagine? I mean, these antennas are losing 11%, 25% of the radio power, okay? And that's why it is important to check that on the antennas you're buying from Algcom, from other manufacturers, because Vswr has a lot to do with the power of reflection, okay? And that's why it is important to check that out once you're buying the antenna. Another ratio, since we're talking about ratio, is the front to back. Here's pretty much the one we hear a lot when it comes to the shielded antennas, okay? Why is that? The front to back ratio has to do with the difference of the main lobe to the back lobes, okay? We've seen the radiation patterns of the shielded antennas. Basically, the idea is to reduce the back and side lobes. And if we are reducing the back and side lobes, that means this difference will be bigger, right? Will be higher. And that's why the front to back FTB must be good, okay? You'll see that the UHBX has a better front to back than the UHB, and the UHB has a better front to back than a dish antenna. And that's because their concept are allowing them to have a better front to back ratio. So theoretically speaking, the front to back is the difference from the radiated power in the main lobe. So here at 0 degrees, and the radiated power in the opposite direction. We have here from 165 to 180 degrees. Okay, that's the difference we are telling you about. So if you look at, for instance, the UHP of 30 dBi, it has a front to back of 50 dB. That means the antenna is shielding 50 dB on the radiation pattern. Okay, and of course the UHPX of the same gain will be shielding even more. Will have a better front to back ratio. And of course, that is important once you have a scenario with a lot of interference. The higher the front to back, the more interference the antenna is shooting. And this has to do everything with the UHP and UHPX line. Okay. We also come here. Another thing interesting to look at the front to back is about the reuse of frequency. Okay. Not sure if it's a Portuguese term or something we created, but basically this has to do when you have like an antenna deployed on the tower, and then you want to put another point to point at the back of your antenna. If they have a good front to back ratio, you know that one antenna won't interfere in the other, because the front to back will be high. That means the antenna almost doesn't have back lobes, and if it doesn't have back lobes, it won't show signal to the back, to the other antenna. Okay, if you put a dish antenna, since the dish antenna has side and back lobes, pretty much will send signal to the back of the antenna and will interfere in the antenna in the second one you are just applying. Okay, that's right. A good front to back ratio allows you to use the reuse of frequency, because both antennas can work in closed channels. One in 5.2 GHz, one in 5.250 or something. That's a reuse of frequency. That's why shielding is important as well, because it allows you to do this kind of scenario. Okay. When it comes to
I guess when I guess when choosing an antenna, this is one of the main things you have to look into, because exactly what Lucas said, when you don't have a good front to back, and you have antennas closer to one another in the tower, you have, besides the frequency, the interference, you have this interference which from one antenna to another. So I guess this is one point that we have to always analyze it very well from one antenna brand to another, because if you don't have a good front to back, it will give you interference to the other antenna in the tower. So always pay attention to the front to back. All these items, all these terms we are explaining right now are very important. Though the front to back is a very important one, especially for that, due to the interference it can be generated by a high front to back region.
That's right. I mean, All these terms are included in our data sheet, okay? But when it comes to the front to back, we even have this tag that goes at the back of the antenna. We have a bunch of tags there. One of them, it's showing the front to back ratio, okay? Because of its importance on the scenarios with interference, that is our main concern, okay? Give the solutions for scenarios with interference. Next topic, also really important and really nice from Algcom antennas, is the support. Okay, remember how Erica mentioned to us that the beam width, or that means the angle of the main lobe, might be really narrow depending on the model. Yes, it is. And what does Algcom provide for make it easier? We have the support. Okay, it is available on the UAGP and UAGPX lines on the 3 and 4 foot of antennas, which allows you to do the azimuth and the down tilt in a millimetric way. Okay, so you can see the screws here, everything here is so you can do the millimetric adjustment for the antennas in horizontal and vertical. Okay, up tilt, down tilt, and here to the right, to the left. That means an antenna that has, for instance, a 2.1 degree of angle. It is difficult, it is, but this support will help you to get the the very top performance. Okay, we say that the beam width of these antennas are just like a laser. You know, those red laser. It's really hard to point at it. And then we have a video here. Let me see if I can play it. Let me just check in here. Basically, it's a video to show. Let me see if I can. There it is.
Yeah, I guess. Okay.
So yes, I'll give you the word just to understand how it works. Okay, so you have this first screw here to do the vertical, so down tilt and up tilt, and then you have the auto support here where you can move the antenna to the right and to the left. Okay, that's why we call it millimetric, because it's indeed millimetric. Okay, I mean in a 50 kilometers link, 1 millimeter or 1 centimeter, it impacts a lot on the alignment, and that's why it's important to have this kind of support. Okay, it helps you to do this kind of adjustment in order to have the main lobe connected to the other main lobe of the antenna.
This is another topic where when we talk about robustness, I guess our antennas fit quite well as well. So we have the deep dish, we have the extended frequency range. The antennas are 100% aluminum made, and we also have the support that it's quite robust, as you can see the millimetric. How can we say, Lucas, millimetrically? I don't know.
Adjustment, millimetric adjustment.
Adjustment. Yes, exactly. So this is another topic to see and observe how robust our antennas actually are. The support is quite hard, right?
Yeah, and also because of course you don't want the antenna to be moving or to be flying the tower, right? I mean, the tower must be really well fixed to the ground, and the antenna also must be really well fixed in the tower, because if it moves, that means you're having instability on your point to point. Okay, and that's something we do not want. Okay. Another point, really interesting, this link polarization. You can pretty much see here, this link polarization, it comes as an option. So we are really used to work on vertical and horizontal angles, okay? But this line polarization allows you to work in a X format, okay? That means 45 degrees. All the UHP and UNGPX antennas come with this option. That means you just need to take out these 4 screws, okay? You have 4 screws here in the feeder. You rotate the feeder 45 degrees to the left, and then you put the screws back again. That's how you do the line polarization. It's really easy, really simple, okay? And then you're now working on an X format. And why is that an option? If in a scenario you have lots of antennas working on horizontal and vertical, the X polarization might help you to escape that interference in a way, okay? That's not something we guarantee it's going to work, okay? It's not like you will use line polarization and then you'll have a better performance 100% sure. No, that's an option. That's something one can not only check when he's deploying the antenna. Okay, if he's in the tower deploying the antenna, he'll try this line polarization and then he can see if it's a better or worse idea. Okay, what also happens, if someone is not reaching this expected signal, he goes for this line polarization, and then he tells me, hey, this line polarization gave me a better signal. Okay, it might have given you, but when you do, or when he did those line polarization, he also realigned the antenna. So It might not just be the polarization. It might be the realignment of the antenna that that allows him to have a better signal. That's the thing we need to evaluate about this link polarization. It comes as an option, and well, it is an option, right? One must test it when he's deploying the antenna. Here's also the support, the robust support we mentioned. Okay, this is probably a 2-foot UHPX model. And since we're talking about alignment, this is it might seem a basic thing, okay, but it's really really important to show you. Of course, the perfect scenario is the main lobe of one antenna connected to the other. If one is not reaching the signal expected, this is happening, okay? Either the both side lobes are connected or the main lobe of one antenna is connected to the side lobe of the other. This is something we come across quite often, okay?
Okay.
You know how in Brazil, we also provide to the telecom, to the Wswr directly, right? So the internet service providers, they call us and then they just send us their print screen of the radios, and they just tell us, hey, I'm not reaching the signal. There's something wrong with the antenna. I've been aligning antennas for 15, 20, 30 years, and I'm not getting the expected signal. What is happening? Okay, I'll explain it. Uh, Let me grab a pencil here. There it is. Okay, so let's suppose this guy that called me is in this scenario here, the first one, okay, the second one. So he has the main lobe here pointed to the second lobe here. So imagine he's now there aligning the antenna, and then he has, I don't know, maybe minus 60 or minus 70 of signal, okay? He starts to move the antenna to the right, but to the right, he ends up losing signal, okay? Because you have what we call as a null zone, where you don't have basically any kind of uh, signal. So he comes back to the first point, and then he starts to move to the left side. But to the left side, he ends up losing signal as well because he has another null zone here. Okay, you can see that's why it has this kind of shape. You have second lobes, then you have a null zone, then you have the main lobe. That's how it works. So if he's moving to the right, he loses signal. If he moves to the left, he's losing signal. That's why, and then he stops. But that's not how it should work, right? I mean, the thing, he should move to the left and keep moving to the left until he starts to gain signal back again. That's what they don't realize. So if they are connected to the side lobe, they just keep there because they are afraid that if they move the antenna either to the left or to the right, they will lose signal. But that's how it works, okay? You will lose signal because you need to lose to gain the signal back again and then connect to the main lobe. Okay, that's something most of them don't understand, and that's why, of course, how are you going to tell someone that has been doing alignment for 20 years that he's doing the wrong way? But that happens, okay? We are not here to judge at all. We are here actually to teach, and that's what we are doing today. And that's
And
why, yes,
that's
tell
why
me.
we say to align ILGCO antennas, you have to be patient.
That's
So
right.
keep that in mind when you're aligning our antennas, especially if it's the first time. Especially for that, you might fall into a second side lobe. So keep it up, even if the signal goes less, right?
Go
Keep it
down.
up because it goes down exactly. If it goes down, keep it up because at some point it go
Up
up
again.
to go higher, and like that you will find the main lobe, and this is the way to find the best alignment.
That's right. And it's so common, as I'm mentioning you, that we created this kind of material in YouTube, teaching them about the alignment. It's in Portuguese, okay, we'll soon have in English, but pretty much what we're seeing is that if someone is moving uh, from right to the left, is not finding the main lobe, okay? Let me just, I think I can grab it here. And then if it's moving on a vertical way, it won't find the main lobe either. That's why it's not going to work. Just move uh, um, right, left, or in a vertical way. You need to do this kind of movement because then you'll find the main lobe. And then once you find the main lobe, you just come back there. Okay, come back here at the red dot and do the fine adjustment. That's a way you can do it. Okay, if one just moves back and forth, right and left, it won't find the main lobe at all. And that's what we started to teach the providers because they didn't have a quite idea about it. Okay, I'll play once again just to understand. So basically, here you can see it here. We call it. Let me grab the laser here. In orange, we have the side lobes. Okay, side lobes here in orange. But the green and the blue ones are what I mentioned to you, null zones. So there's no signal here and there's no signal here. So you can pretty much understand now that if one is locked here in the green area, if it moves to the this side, it won't have signal. If it moves to this side, it won't have signal. So that's when they just keep in this whole side lobe, because they are afraid that if they move any different from the other side, they'll lose signal. And that's indeed the truth, right? But then it comes when I mentioned that you need to lose sign. So you'll lose sign here in the green area to come back and gain sign here again in the main lobe. Okay, that's the whole concept of alignment, and that's why it's important to keep trying and keep aligning, because at some point you will reach the main lobe. Okay, it's not a fairy tale. The main lobe does exist. It's just sometimes a little hard to find. And as I mentioned, the bigger the antenna, the smaller the angle of the main lobe will be, and of course that's why we have these supports, the fine adjustment support I mentioned before. Okay, here's also an invitation for you to check our YouTube channel. We are working a lot on English material for you guys, so you can just teach more about the brand and teach more about the products, and of course share a bit of your experience with our solutions. Okay. Moving on, then we have the shielding. Pretty much the most visual difference we have from the antennas, from a dish to shielded antennas, okay, it is the shield. So the deep dish concept, as I introduced it before, and for the UHPX, we have the extra shield. So that means an aluminum protection that will help to shield interference even more than the UHP. Inside the UHPX, we have this foam. It's a RF absorbing foam of graphite. Okay, why is that? Because this graphite helps you to shield the interference. It helps something like 0.8, 0.9 dB. Okay, but it's helping. And it comes again the fact that we are thinking about everything in the aspect of the antenna. Here is not just the extra shield, but it also counts with this foam, with this protection within it. Okay, one important thing to check is about the lateral, this point here, where we say the lateral shield does not work for frontal noise. And what is that? What does this mean? This means that in either models, okay, you have interference coming from the side, right? Okay, so we have the shield that is protecting the antenna, and we have noise coming from the back. Okay, so the antenna pretty much is shielded in the 90 degrees, okay, and is not hearing anything in the other angles. But if 30 kilometers from this antenna, I have a tower here, and there's one antenna which is not connected to this one, okay, but its main lobe is really close. That means someone maybe aligned it in a wrong way, and it's coming a main lobe here to the antenna, which is not supposed to. Okay, this antenna is connected to another one, maybe one here below. What happens? The shield, of course, won't be able to protect this antenna from the main lobe, or from the frontal noise we call, because does not have any kind of protection in the front, right? It's not supposed to. If you put for instance, a aluminium here at the front, it won't work at all. It won't be able to issue any kind of signal. So that's why we say the lateral shield, the deep dish, or the extra shield do not work with frontal noise. And sometimes this happens. So someone sends me a spectrum analyzer, and there's so much interference. He's tried the dish, he's tried the UHP, he's tried the UHPX, but nothing works. And why is that? Pretty much he's locked with a frontal noise, and indeed nothing will work but change the antenna in the place of the tower, right? Maybe putting higher or lower in the tower, or changing the way, something like that. Okay, that is not going to work. Any kind of shield in the market will help you against frontal noise. Okay. Another point interesting about the shielding, and a question we get quite often, is about the dish antenna that someone puts the radar. Okay, so we've seen Algcom has a dish antenna like rocket dish, and someone might buy an antenna dish from Algcom, and they ask us if they can put the radar. That means the shield. Usually it's a homemade shield someone does with aluminum parts, and why is that not recommended, or why is that not possible? Two things. The first one, ALGCOM products and ALGCOM itself are homologated in Anatel. Anatel is this part of the Brazilian government that certificates everything related to the telecom. That means the manufacturers, the ISP themselves, okay? And the government says to us, or demand us, that any product we do cannot be changed, either mechanically nor electrically. So that means if we have a dish antenna and someone puts the radome, we are changing the characteristics, the aspect of the antenna, and that's not legal. Okay, not here in Brazil, not if the product is certificated by Anatel. So that's one reason you cannot put the radome on a dish antenna by Algcom. But more important than that is that you are affecting the radiation pattern of the antenna. And why is that? Look at it. The first one we have here, the first radiation pattern, we simulated a dish antenna, okay? When someone puts the radome, puts the shield, okay? What is happening here? First of all, you're pretty much hearing interference here at 90 degrees, okay? You can see that you have this lobe here at 90 degrees. The second thing is that this antenna, remember we saw the radiation pattern. The radiation pattern was showing to us that this antenna had side lobes here, right? I mean, a dish antenna has side lobes, and the side lobes are supposed to leave from the sides, right? That's how the antenna was first developed to work. If someone puts the radome, that means the side lobe that should leave the antenna is now reflecting it internally. So it's now coming back because someone put the radome, right? Someone put aluminum thing here, and now the radiation pattern or the second lobe is coming back to the feeder. It's not leaving because we are not allowing it to leave. And now, of course, if it's coming back, it will interfere your performance, right? This comes back as interference and, of course, as a sign of power, a sign of gain, okay? That's why it's not recommended. So why Algcom has a dish or has a shielded? In this case, the whole antenna was thought from the beginning to having the shield. Okay, remember, the lanes also have a radiation pattern, and this lane here already knew the antenna would have a shield. So we calculated the lane, the radiation pattern of the lane to the plate as having the shield. And that's why in 90 degrees you won't have interference. That's why you have the whole main lobe here. Okay, everything is focused to the main lobe because from the beginning the antenna was thought to having the shield. Okay, a dish antenna was thought from the beginning to be a dish antenna and won't perform as a shielded. That's the reason, and that's something really important. Of course, we will have some kind of improvement in this case. Okay, if you put the shield, you'll have some kind of improvement, but won't compare to an antenna that was thought from the beginning to having the shield.
Yeah, this is exactly how we maximize the main lobe. Due to this, all wave electromagnetic waves go from the form, and it is maximized on the main lobe to the distance until the other antenna, right?
That's right. And then we come up with another interesting fact, and also something people don't actually some don't understand. Okay, and that's something we bring as a matter of fact about the radome. So we've seen the shield, right? The shield is this aluminum part of the antenna, which is indeed shielding the interference, right? Because it's aluminum. And some people ask us if the radome, that means this protection in the front, is doing any kind of protecting the antenna against the noise. So what is the function of this thing here, plastic thing? So for this question, the thing is, it's a myth, okay? The radome, this plastic thing, does not help the antenna against the interference. So what is the function? Of course, the first one is to protect the antenna. So it won't enter any kind of water, any kind of birds, or any kind of animal within it, and it won't damage the lens, okay? But most important is that the material of this protection and the shape of it, it is to be the more transparent as possible. So what does this mean? This means that we are developing this so it won't interfere in the radiation pattern of the antenna. That means the radiation pattern cannot see this plastic here. And that's why here again everything is taught the material, the width of the material, okay, in the shape of it, everything is taught to be as transparent as possible so we won't interfere in the radiation pattern. Okay, does not have to do with shielding the noise. It's actually the opposite. It must be not useless, but it doesn't have a function when it comes to interference. Okay, it must
Yeah.
be visible.
Sometimes I get usually I get the question: does the radome isolate noise? Does the radome has to do something with interference? But the answer is no, because exactly as Lucas mentioned, to isolate noise, we'd have this to have the same material as the antennas, that is aluminum. And if we put aluminum on the front of the antenna, it won't go able to
To
go
send a signal.
past the exactly.
And that's why they're
So
plastic, right? They're not aluminum.
exactly. They're plastic made, so they do not help with interference. They are just a protection against birds and waves, weather, and everything else.
That's right. Another, and then already coming to the accessories we have. Okay, almost finalizing the presentation. One of them we have is the cable. Okay, as we mentioned, the antennas are connectorized, so that means that's what makes them compatible with any radio in the market, because you just need the cables to connect it, and the cables are also manufactured by Algcom. And as everything we do, we're looking for quality. The cables are also high quality cables, as we call, for a few things. The first one, the loss. Remember, I told you there's no perfect scenario, and there will be a loss or a reflected power from the radio to the antenna. Our commitment is to reduce the loss of the cable. That's why every single cable you'll buy from Algcom, it will go with a test report. A test report that is assuring you that this specific cable was tested before leaving the factory, and it won't have a loss bigger than 0.7 dB. Okay, usually 0.5, but our limit is 0.7 dB because we are assuring the maximum loss of the cable. That's why we call it them low loss. Its loss is 0.7 at max. Other nice thing is about the connectors. As a pattern of the market, ALG come with SMA connectors. Okay, pretty much a pattern of the Brazilian market. We just keep following. But the radios, they have a bunch of connectors. An example, for instance, the Mimosa. If you grab the B5C, they'll have N connectors. If you have the C5C, they'll have SMA connectors, right? So ALG also is compatible. The cables are compatible with the radios in the market. MMCX, it's the rotor board. If one just buy the board of the radio from MicroTik, it will have a different connector, so that's why it makes them really flexible no matter the radio you're using. Okay, and also the VSWR. So the reflected power in the cable is the lowest we have in the market. Okay, so a few fun facts that are really interesting, and they're here to support us our discussion about quality in products. Okay, including if you look at the connector of the cable, you'll see it's gold plated. That's not something we do in Brazil. Okay, we import from German, so it's really a gold-plated connector because the this material and the in the format of the material allows you to have some nice low loss cable in there. And finally, the other product we have, which is really interesting, is the armored box. So what is the concept of the armored box? As we have the shielding of the antenna, right? We are shielding the antenna against the RF interference. The armored box allows you to shield interference in the radio. Okay, the antenna is not the only equipment that generates and hears interference. The radio also does that, and that's why this armored box is interesting. Basically, it's an aluminum box, okay, 2 millimeters, and we put the radio within it. Besides protecting the radio against RF interference, we are protecting the connector, we are protecting the feeder, the cable, everything is really well protected with this armored box, but pretty much is to protect the radio against interference. And here there's a nice comparison we like to share. Imagine that you are at a party, okay? So there's a lot of people there, and then you want to talk with someone. There's some nice girl there, and you want to talk with this girl. You need to scream for her in order for her to understand you, right? I mean, there's some loud music and people are just singing some other songs. So I'm going to talk with this girl, and then I need to scream so she can hear me, and then she needs to scream me back so I can hear her, right? That's not nice. I mean, that's not health for my voice. That's not health for the scenario, right? I mean, if we are screaming, everyone else will start to scream, and that's what interference is about. So let's suppose I invite this girl to go to a separate room, okay, a quiet room. What happens now? We don't need to scream anymore. So that means we will we will talk in a moderate voice, right? I mean, just like I'm talking with you today. So what is this? The separate room? This is the armored box. And what is the voice I'm telling you we need to scream? Is the power of the radio. So if I'm putting the antenna or the radio in a quiet room, I don't need to set my power in the maximum, which is really common. Someone just deploys something and then put the radio power at max 29 30 dB. But if I'm protecting the radio, I can modulate better with a lower power. Okay, that's the thing. That's why it's important also to protect the radio against RF interference. And indeed, we have a lot of case studies on our social medias proving that. Okay, people are using this a lot here in Brazil. Of course, what happens is that new radios are already somehow shielded, but for the old ones, especially the ones with N protocol, they are not. or some of them come in this plastic case, right? And this is the option we have, so you can protect the radio and work in some health power, in some health scenario.
This
Okay.
is this is a quite nice solution for where you have an extremely a high noisy level with scenario, and you have the UHPX, and this is an extra solution where you can find to also isolate noise and have a better scenario. And along with the pigtails that have a very small loss, these are the compounds together that make you with a great performance. So with a good antenna, with good accessories, you have a great performance.
That's right. It's actually this kind of marriage, you say, right? You need to marry the radio with the antenna with its accessories. Okay, if you marry them all, we'll sure you'll have a great performance. And basically, the idea today was just to show you that it's not just about the shield. Okay, it's not just about this name of UAGP or UAGPX. We're just wanting to show a bit of what makes the antenna to perform the way it's performed. Okay, it's not a single thing. It's not a single solution. It's not a single term or thing we are adding to the antenna, but you understand that everything we thought in the antenna was thought for the best. Okay, it's important also to be up to date to our social medias. If you look at the Instagram and Facebook, there are dozens and dozens and dozens of groups of the WISP community there. It's important to see what people are telling not only about ALG but about the market in general, right? The WISP community is really open. They like to share their experience and check new technology, new solutions. So that's something we also tell you or suggest you to do to keep up with the social medias and of course with ours as well on Facebook, on Instagram, on YouTube. I think next week we'll be launching some videos in English starring me, just to present just presenting some difference about the point to point and point to multi-point solutions we have, but pretty much the invitation to be really well connected because there are a lot of information in the internet, and if someone needs something or any kind of support, we are here for you. There's Felipe, Erica, me, and the whole ALGcom team behind us, and of course Fornet as the channel in America. Okay. Not sure if you have any kind of questions from the chat or if someone wants to share something.
I guess we are good, Lucas, from the chat. Yes, we don't have questions right now.
Okay. So basically, I also appreciate Franklin. We had another webinar yesterday, right, with Latin American guys, which was just awesome. And I'm pretty sure the idea is just to keep up with these webinars for America, and of course, everyone that speaks English is invited because ALGcom has the idea to keep teaching the market and also learning a lot from you. We are daily in contact with those 30 countries I mentioned, so we are indeed learning a lot. And the idea is just to bring some of the case studies of the experiences the others are doing to you, so you can also have some nice idea of the market, what is working and what is not.
Yeah, we will try to continue to do in a monthly basis so we can reach more people on the United States and the Caribbean. We try to focus on the Caribbean too, on the islands.
That's right. That's
Mhm.
right. Awesome. So thank you guys for your attention. Thank you, Erica, Philippe, and Franklin. But thank you mainly for the ones that were here today. We're also accepting any kind of ideas for webinars. So if you have anything you should we should talk about, just let us know. We'll sure think about something, and we'll be working more content for you guys to be up to date with our news. Okay.
Okay. Thank you very much, everyone.
Thank you guys. Take care. Have a
Bye.
nice end of the week. Bye.
Bye.